Hi, welcome to this episode of Let's Live Code. Last time we examined how to create a framework that can be used for live coding. The framework consisted of three different sections. The first section where we declared our instruments, the second section which consisted of an audio processing section, and a third section which was a playback system using pbind-def. In this episode, instead of using synthesis to create sounds, we're going to have all of our sound sources be audio files from our desktop. So if you're following along, you might want to stop for a second and pull some audio files onto your desktop. And as you're doing that, I just want to take a second to reiterate the scope of these videos. These are not intended to be a step-by-step walkthrough of all the functionality of SuperCollider. And the reason I do not do that is just because I believe that there's already a lot of really amazing videos that you can find on the internet for that explicit purpose. Namely, Eli Fieldstill's SuperCollider videos are really wonderful at that. So if that's what you're after, I'll go ahead and link to those videos below. And the reason I chose to do these videos, as a composer, I feel like sometimes it can be intimidating knowing where to start with coding. That's why the focus of these particular videos is about application. How can you use SuperCollider to make and manipulate sound? So if that's what you're interested in becoming more flexible with the language, then that's what these videos are designed for. I'll produce all of the code in each of these videos as I work, and then I'll try to hone in on some specific strategies for working with the code that I found useful. There's an endless variety of ways to accomplish ideas with SuperCollider. So if you know of another way that you think works better, please let me know. I hope these videos can foster some dialogue back and forth. So for today, there's really two main ideas that I want to try to get across with these audio files. One, I want you to look at some strategies for creating a variety of different sounds from sort of limited sounds or just a couple of audio files. And the second one would be that I want you to create some sort of synchronization system for the tempo. Now, with these audio files, there's a lot of different ways that you can go about this. You can create a dictionary of hundreds of different sounds, but to me, it almost seems better to work with sort of limited sounds and try to get a lot of variety out of those little sounds. That way they sort of seem organic. So we're going to start with s.boot, which is just server.boot. And then I'm going to go ahead and start recording this session by giving it the command server.default.record. And to begin by playing any sort of sound files, we are going to need a place to store those sound files in order for us to be able to read them. And the place that we store that on our computer is going to be a buffer. So we're going to declare a variable and store our sound files that we want to record in a variable. So right now I'm going to say b equals buffer.read, and then S stands for the principal server, comma, and then whatever the path of the sound file is. Now, we're just going to go ahead and drag these literally from our desktop into our system, and that's a good enough method right now for keeping this organized. For more elaborate setups, you might want to hard code in where the sound files are and have them sort of declared. But for now, since this is just a one-time, one-shot thing, clicking and dragging them in works just fine for us. So B right now is going to be equal to our symbol. And you notice that after I declare that, it says buffer, comma, 1 in the PostScript window, which means that we are using the first buffer and we're storing our symbol sound in that first buffer. That's an important thing that you're going to need to know as we keep on dragging these files in. So if I go ahead and drag my hat in there, and if I go ahead and drag my kick directly in there, and then I'm going to go ahead and drag my shaker. Come on, drag my shaker. And then I'm going to go ahead and drag my snare. And then we'll go ahead and drag my bass. But every time I evaluate that now, it's using the next buffer in a system. So buffer 2 now is going to be equal to my hat. And then if I evaluate my kick, buffer 3 is going to be dedicated towards my kick. When I evaluate my shaker, buffer 4 is going to be dedicated towards my shaker. And buffer 5 will be dedicated towards my snare. And the beauty of having this all set up this way is that now if I want to just go ahead and test the files to make sure that we can read them off of our buffer, all I have to do is say b.play, and it should be playing my symbol like so. And then we can change our variable and change it to D to go ahead and check the other ones. And that's all of the sounds that we're going to actually be using to create music today. If we stack them next to each other, it would probably be about 2 seconds of music. And then in order to use this in a more flexible and sort of organic way, we're going to need to go ahead and make an instrument out of this. So now that we have our sounds loaded in, let's go ahead and create a synth-def so we can go ahead and play these back. So synth-def.new, and the name I'm going to give my symbol is symbol. It's very creative. And then again, I like to code from the outside or from the inside out. So typically I declare my arguments after I declare or I figure out which ones I'm going to use. So the signal that we're going to be using is playbuff.ar. It has 2 channels. And here's where the buff num comes in. The buff num then, if I want my symbols, is going to be 1. And then the rate, we can set that up as a variable right there. So the rate is going to be equal to 1. It's a 1-to-1 ratio. And these other ones, trigger, start position, loop, none of those really work out well, but I am going to want to free it from the server. So I'm going to give it a done action to method. And here we're going to do something a little bit different than we did in the first video, which is we had a separate section in that video for an audio processing effect. I'm going to go ahead and declare a filter right here that I can use to filter out any of these sounds. Right now there is a wonderful Moog ladder filter that's built into Super Collider by Moog FF. It's going to move at the audio rate, and it allows us to then go ahead and put our input, which is our signal, our frequency, which is going to be our cutoff. We can do the amount of the gain of that frequency at the cutoff. And those are going to be things that we just can alter later on as we're coding. And we can do it individually for each instrument, and that'll be one of our methods for going ahead and getting a variety of different sounds. And to just go ahead and get some volume control on that, I'm going to go ahead and multiply that by another argument for amplitude. And I'm going to give us another argument for an out, and that way we can go ahead and declare where we want this sent out to, either an audio processing buffer or just sort of the regular out. And right there for the bus, I'm going to say out is going to be where we're sending this, and our signal is the thing that we're going to be sending it out. And as soon as we add that and evaluate that, if I've done it right, which I have, you'll see a synth-def in the PostScript window. And then all I have to do to be able to play that synth-def is say synth.new, whatever the name of that synth is. All right, wonderful. Now that I have one synth-def that I know is coded right, we're going to be making copies of this, obviously, to copy our other sounds into our synth-def. So I need 5 or 6 different copies of this, which I'm going to go ahead and make. And now all I really need to do is change the name and the buffer number, and I should get all of my different instruments. So instead of symbol here, I can go ahead and put hat and change the buffer number to 2, because if you remember, hat is coming out of buffer number 2. Of course, I did that in the wrong place, so let me go ahead and fix that right here. I like to try to keep myself as organized as possible. Hat coming out of buffer number 2. Now in buffer number 3, we're going to be using our kick. Put that in right there. In buffer number 4, of course, we're going to be using our shaker. And we'll go ahead and put that in right there. And in buffer number 5, I'm going to be putting my snare. And I can put that in right down below. And of course, I wouldn't do anything without having my bass. And I will put my bass in buffer number 6. If I look over, all of those should match up to where my buffer numbers were declared before. And if I go ahead and evaluate all of that code, it should say a synth-def in the PostScript window, which it does. And then I will go ahead and copy the synth.new just so I can check to make sure that all of this lines up with the names that we have declared for this in case I made a mistake about where my buffer numbers were. So I have cymbal, hat, snare, shaker, kick. And let's go ahead and test those. All right, and everything sounds just the way we expect to, which is what I like to, that's what I like to hear when I'm coding. And then finally, the second thing we're going to do now is I'm going to declare an audio processing section, just like we did in the first video, although it's going to be a completely different audio process. We're going to use a delay line to go ahead and create sounds of delay in our audio. And to do this, first off, I'm going to use a variable of sig. That sig then that we're going to use is going to come in on bus 20, just like we had on the first video. So I'm going to go ahead and say sig equals in.ar, and the bus number that I'm going to use for that, it's going to send sound in on 20, and it's going to read 2 channels, because each one of these stereo audio files that I have are stereo, so they're 2 channels. And then there's a variety of different delays we can use. There's cubic interpolation, but I'm actually going to use delay that has linear interpolation, the one that's right below it. And the reason why is it's computationally less expensive than the cubic interpolation. So it's a little bit easier on our computer. And then the variables that we have are in. So the in is going to be our signal. And then we have a max delay time, which is our buffer time, and then we have our delay time. So I'm actually going to do a little trick here, is that I'm going to declare a variable for delay time, and I'm going to set that to be both the max delay time and the delay time. So anytime I update my delay time, I'm automatically updating the buffer time to scale exactly to whatever the delay time is. That way we don't have any sort of, our buffer max delay time isn't long as our delay time problems. And then our amplitude is the amount of the signal that's being delayed back. And then if you don't have your signal coming back in at the end, you know how I declared sig right there at the end, you're just going to get a delayed signal, which doesn't seem like it's delayed unless you're playing against something that is delayed. So you need to have that sig right there at the end if you want it to sound like a delay, because you want to hear those 2 copies of the signal. And I press .add and go ahead and evaluate, and I should get a synth-def in the PostScript window, which I do. So everything is hunky-dory so far, but the effect is not going to sound until I declare it in a variable, just like we did in the last video. So x equals synth.new delay. I go ahead and say that, and now my delay is running on 10:15. And I can use the set message now to go ahead and declare variables for my delay time and for my amplitude. So right now we'll just keep it simple. We'll say our delay time is going to equal 0.2, and that our volume of that delayed signal is going to be something that's less than 1. In this case, we could say 0.7. And as I evaluate that, if you look over in the PostScript window really quick, you can see that delay is being set to 10:15. So it's being sent to the delay effect that we already had put on the server. If you didn't use the set function for that, then you might be declaring multiple versions of delay on there, which could eat up computer processing power. And then I'm going to go ahead and start a stream of kicks. So we're going to use pbindef is going to be our clock. That's the thing that's going to be running our sound file kicks. The name of the instrument that we're going to be referencing is kick. That's the synth that we're going to be looking at. And then the rate is going to be a 1-to-1 ratio. I just want to be able to hear my kicks right now. And the duration is going to be a little bit different. There's something in the background that's running at all times called tempo clock. And right now, tempo clock is being set, I believe it's at quarter note equals 120. So if I did 4 quarter notes, it'd be 4 quarter notes at 120. But I can also declare a different tempo. Now you can do this either by declaring a different tempo clock like I did in the first video, or another method, which is maybe a little bit more flexible, is I can just use the stretch function to stretch a certain sound file over a portion of the bar. Now, the method for doing that would be to say 60 beats per minute over 132 times the number of beats in the bar. So right now we're going to just say this is a bar of 4/4, so it's going to be times 4 beats. That gives us 4 beats of quarter note equals 132, and since the duration that I'm using is a quarter note, I should just get a steady pulse of quarter note kicks, or 4 in the floor. The next key that we're going to be looking at in pbindef is going to be the amplitude. So right now I just want to move that as 1. The cutoff of our filter, which is going to be, since we're dealing with kicks, these are fairly low sounds, so we're going to say like 600 hertz or so. And then we can say the gain of that cut from the filter is going to be like 1, 2, or 3 are really the most useful variables, but we'll just go ahead and put it right in the middle and say 1. And then the bus that we're going to be sending this out to is going to be bus 0. And if we go ahead and say play, I have 4 quarter notes. Okay, and that was just to show you a little bit of demonstration of how we can get some variety from the sound files. Playing with that filter, then the cutoff of that filter, the lower that filter is, obviously, the duller the sounds are, and the higher that filter goes, the more of those higher frequencies we're adding back into the signal. So we're able to actually change it and make it sound like it's different sound files. Now that we have our 4 on the floor, let's go ahead and bring some of our hi-hat sounds back in and try to get our hi-hats to play off of the sound of the kick drums. All right, so now we have our kick drums playing, and if I go back in and I add in my kicks, you can hear clearly that they are not lined up together because I evaluated them at different times, which stinks because if we're live coding, I want to be able to bring in sounds and bring out sounds organically and have them automatically snap to the beat. And the way that we're going to do that is by being able to quantize the sounds together. But before we go ahead and do that, let's talk a little bit about global variables. Right now, I'm declaring a global variable that's named MVL. And I'm just saying that MVL is going to equal to 1. And what that little bit of code does, if I go ahead and multiply that by times my amplitude or my volume, now what I've done with just sort of 7 characters of code, I've went ahead and I've created a master volume system or a routing system that I can go ahead and I can use to control the volume of all of these. So if I want to fade these out now, I can say master volume level is going to be 0, and now I have them turned off, even though pbindef right now is still playing. And if I go ahead and evaluate that and reevaluate my code, I have it playing back and forth again. This I find is a really handy way to sort of go ahead and create automatic starts, automatic stops, to do gradual fade-ins, to do gradual fade-outs, to have certain sections doing that by creating sort of a submix section within there. So now that I have that system done, let's go ahead and look at ways we can go ahead and get this to play with each other. Earlier I mentioned that quantization is the way what we wanted to do. And right now, these are moving at the same rate of tempo, but they're not moving at the same part in the beat. So if I give it the quantization of 60/32 times 4, then I'm saying that it should line up with the rhythm that we have right now. So if I go ahead and stop these, and then I go ahead and bring, say, maybe either my kicks or my hats back in, let's just go ahead and bring in my kicks one at a time. I can start my kick, and now when I start my hat will be timed exactly with my kick. Just like that. And that's how we create a tempo system that we can use to sort of synchronize with each other. Let's say I wanted to move the hats at a different tempo. Let's say at 1/8 notes. We're getting crazy now. All right. And now let's say I wanted my hats to play off of my kicks. We'll go ahead and turn this off for right now. See how well that works out? If I wanted my hats to play off of my kicks, then what I'm really saying is I want the amplitude of each of these 1/8 notes to be off on. And I can declare that by using the pseek method. I can create a list that says I want my amplitude to be off, and then I want my amplitude to be on, and then I want that to happen an infinite number of times over and over again. And if I go back over to maximum volume level, turn it back on, turn my kicks back on, and now we have our kicks playing, and our hats are playing off of our kicks, just as God intended. All right, so now that this is working out just like we want it to, let's go ahead and take out the hats for a second and just look at the kicks. So it's great that we have a cut that's set off right now to 500, but I want the computer to be able to offload some of this randomness to the computer. So if we use the key P white, which enters a random value of white noise into our number stream from 400 hertz to 575 hertz an infinite number of times, if you listen to the kicks now, there's a little bit of variation there, but it's a little bit subtle. So we're going to go ahead and make that range a little bit wider. And then, of course, we can enter that same randomness now into our gain. Maybe from 0.8 to something like 2.4. There we go. Now they're starting to sound like different sound files. Of course, I can go ahead and enter something similar in for the amplitude over here, right? I can have a sequence of amplitudes. So right now I have a quarter note that'll be on the downbeat and then on beats 1, 3, and 4. There we go. 3, 4, 1, 3, 4. And now I can go ahead and bring back in my hi-hats. So this is just a really basic way of being able to play back and forth with each other, just using our kicks and our hats. But you'll see me do the same thing as soon as I start bringing in all these instruments. I'll look for ways to enter in randomness or to explicitly state where I want these notes to be by using pseek, or sometimes by choosing a random value by using prand, which creates a random list an infinite number of times. Okay, before we actually get to the coding portion of this, or the live coding portion of this, I want to talk a little bit about the bass, because I'm going to use the bass for two functions. I'm going to use it as my bass, but I'm also going to use it as my melody function as well, just because it has pitch to it. So let's go ahead and copy our hats like we have right here. But now I'm also going to go ahead and simplify the version of it. So our bass right now, I'm going to put the filter almost all the way up. So we're going to not filter a whole lot right now. And we have our bass quarter note equals 132. There we go. And it'll just keep on playing that bass over and over. But if I change the rate, now it's an octave higher. And if I do the rate 3 times higher, now it'll be an octave and a fifth higher. And if I change it right up, it'll be a perfect fourth above that. And if I change it up high, it'll be a minor third above that. And basically we have also Sprach playing because it's the harmonic system. So I can offload what notes are playing what by changing the rate of playing here. In this case, we're going to use white noise and say pick a random number from 1 to 5. And now the computer is playing a bass line based off that one bass tone. And I can change that to be any sort of set value that I want to. So now that's all set and good. Let's go ahead and create another stream of basses. We'll call this play system basses 2, and I'm actually going to use this to create a melody that's also based on the harmonic system, so it should be harmonically fine with the bass line that's going on, and I'll have that moving at a faster rate. Once we go ahead and evaluate that, great, now we have eighth notes moving on top of quarter notes. And all is right in the world. We're going to go ahead and stop this for a second. I'll stop my bass, and I'll stop my melody, and I'm going to look for another way that we can use a global variable. Before we used a global variable to control our master volume level, so we had a submix. But now I can use a global variable to actually transpose the harmony of the piece. So I'm going to say that global variable is TSP. It's going to equal 1. And all I have to do is multiply that by the random value of the rate. And then we have a value that we can use to shift. Now, all of those transposing rates, as soon as we bring this back in, since it is equal to 1, it's the same value that we had before. But if I go ahead and change this now and reevaluate that, and then reevaluate the code, now we have different harmony all of a sudden. So it becomes a really easy way to get sort of a little bit of variation out of these audio files so we have different sounding harmony. And that seems to work out the way we want it to as well. So the next thing that we're going to be looking at doing then is just bringing in all of our other instruments. We have our kicks, we have our hats, we have our basses, but that still means that we need our shakers, our snares, and our cymbals. So just simply copy and paste, and then go ahead and change the name. So we'll bring in our cymbals, and then we'll go ahead and bring in our hats. As such. Although, you know what, now that I'm thinking about it, we were playing the hats off of the kicks. So I think we already had the hats in there from up above. Let me just go ahead and check that really quick. We'll just make it a shaker You are a shaker now. Should be shakers. It really doesn't matter if we don't change that name as well. And then we'll go ahead and bring in our snares. Yeah, shakers. And then we'll go ahead and say that that is snare. All right, I think everything is well and good. I'm going to go ahead and start with just the kicks, and then I will go ahead and just bring in instruments one at a time, trying to create some variation with them, trying to get them to play off of each other, and trying to create something interesting that sounds fun. So with these shakers here, I'm actually going to go ahead and create, copy and paste this piece sequence to create a much more complicated rhythmic figure. And you can think of it at almost, since we're having half notes, every 2 beats then is going to be 1 bar. But maybe I want something that's going to move a little bit faster. So each of these, I could have them be 16th notes, in which case you have a measure of 16th notes, or 8th notes, in which case you have 2 measures of 8th notes, whatever it's going to be. But it lets you go ahead and create a sort of more intricate pattern than what you would typically have. This will actually be way more useful when we're going to be using the snare drums. So let's go ahead and just use that to create a pattern out of our snare drums. One thing I haven't really talked about much here is the delay line. So let's go ahead and bring in that delay. Right now we will go ahead and start there with a kick. And yeah, that kind of thickens the sound up. Let's bring it back in with a bass. Yeah. You can hear it right there in the melody line as well. It's starting to get a little bit different. And let's make those values a little bit different. Play with the delay time. Play with the volume level that's coming back in with that delay line. Yeah. thing I like to do is I like to slow the rate of one of the instruments down drastically and cut out everything altogether to start up creating a new session. So while we have something that's really beat-based right now, if I take the cymbals and stretch them out to almost 0.01 or whatever it was I did, and then every 8 beats or 8 bars, it changes. If we evaluate that now, we can start to hear that is just the sound of the cymbal, and it sounds like a drone. And then I'll go ahead and bring snares back in. And since I have this drone going on and I don't have any of my harmony going on right now, let's go ahead and take that time as an opportunity to go ahead and update the transposition value now. So when I do bring in my melodic instruments and my bass, they come back in a different harmony. And something I didn't really show before, in our melody voice then, I can actually use prand to, right now it's going to pick a randomly it's going to pick either a 0, a 1, or a 1 as its value. So right now it has a 2/3 chance of picking a note, or a 1/3 chance of not picking a note, which is going to add sort of a stop or a pause in between my melody every now and then, which makes it sound a little bit more human. And that's going to do it for this episode of Let's Live Code. I hope you enjoyed it. I'm thinking that next time we have a video, we're going to do something by using granular synthesis, since we're already talking about playback files and ways to sort of use that to manipulate and create new things. So